Hello, class. So I'm coming to section 3.1 and point one. So actually, this one is in section 3.1, but I want to separate that and make this in a small, small topic, and what we call like graphs of exponential functions. Okay, so we have some elements that all exponential functions have in commons, and we have the form using with the factor, the growth factor form as a times b raised to x. So when I got this is a growth factor form. All right, so we need to consider about something such as y-intercept. Use this one. Okay, y-intercept must be 0, a. So this a is what? A is initial amount, initial value. And also a is value of fx when x equal to 0. Okay, so we have y equals 0 will make a horizontal asymptote, and for this case, functions will approach x-axis on one side. So one more, let me highlight this one. All right. One more thing is as domain of the exponential functions is all real number. Keep in mind that this is just mathematics, just for mathematics. Okay, for the business people, we don't gonna consider about the negative. Okay, just gonna tell you that for business or for business business class, you may only consider from 0 to positive infinity, right? Then we have the range. Okay, so the range of the function will be 2 Ks. Okay, it could be in between 0 to infinity when you have a is greater than 0, where the initial amount is greater than 0. If you have a less than 0, you will have the range will be from -infinity to 0. Okay, so let's take a look at the graph up to this case. Maybe I want to use other color for. Let me see 1 second. Not using this one. Okay, so I will say 2 Ks. 1 K is when you have positive a, and mostly we mostly consider about this case. in this class. Yeah. So because the initial values we usually, I mean, in our class mostly is positive, right? So we in our class mostly we consider about this case, and for this case we also split to be two small case. The first small case is the case that you have b greater than 1, and the second case is when b in between 0 and 1. And as you see now, like I told you before, when b is greater than 1, you will have a increasing growth, or we have like growth exponential graph. Okay. For the case that's b in between 0 and 1, you have decay exponential. Or maybe I'm just gonna say grow and decay, but that's more space. Okay. All right. And look at both of them, the range, it just comes from 0 to infinity. So look at the range. Here's range, right? Range. Right. So if you see the range in the case that positive of A is always from 0 to positive infinity, you can actually tell, you can actually know that, oh, these the case for our class, right? And also we know that the initial amount must be greater than 0. And you see that the initial amount is always going to be the y-intercept. Is as the y-intercept of the graph. Yeah. So that is what we have for the case of positive A. However, since we're gonna need to learn a little bit about math, let's also touch with negative things. So in the case with negative A, we also split into two cases. The first case is when you have B greater than 1. And the second one also have in between 0 and 1. Okay. So you will have the difference was the range now just gonna be from 0 down to negative infinity. Keep in mind that the range is how vertical it is. Okay. So, and the y-intercept still gonna be the same as before, which is 0 and comma A. 0, comma A here. Okay. All right. So now I'm gonna move to the next things. How do the graph change when you change the parameters? Okay. So the next topic is we want to try to figure out which one is for which one, maybe. Okay. Now let's take a look at the first graph here, changing B. All right, changing B is changing a factor. All right, this is meaning change the factor. Right, the growth factor or growth or decay factor, something like that. I usually call it growth factor. Okay, and that's, take a look at that. You can see, for example, in here you have you have some decays, 3 decays one, right? Right, 3 decays here, right? So if you have you have like 2/3 compare with 1/2 and compare with 1/3. So as you see that since the base, if the base is higher, like I'm going to say like, yeah, sorry, if the growth factor in this case, actually, this is the decay factor. Let's say that. Okay, maybe the right hand side is change the growth factor, and this left hand side gonna be change the decay factor. Because that in the left is the one that's the left is the one that decays. So I wanna make sure you see that. Okay, so change the decay factor, make you see that if the factor like close to more close to 0, it decays faster, and you see that, right? And going down quickly, right? And it decays faster. Something like that. And for the one with higher, like bigger decay factor over here, because usually if we call like decay, it's gonna be a negative number actually. Okay, I wanna change this word. I wanna change this word. I don't wanna write this. I don't wanna using this decay on. Change this become decay. Change this become row. Okay. All right, so and you see, if you have, and you see 2/3 is greater than 1/2, and 1/2 is greater than 1/3. So the more it's close to 0, the more it's quickly decay, or like it decay faster. Okay. In another side, if you have the growth factor as 3 compared to 2 and 3/2 here, they are all greater than 1, right? So you will have the one have higher growth factor. It will be increasing quicker. Okay, increasing quicker, like faster to the positivity. To the other hand side, if you want to change the initial amount, okay, so let me say changing B, growth factor or decay factor, let's see that, right? And the other one is changing A as initial amount. So it will move change your y-intercept, right? As you see that if you have 4 as the initial amount A here, it will be in if you have y-intercept as 0, 4 there, right? And if you look at the function that y equals 3 times 1.2 to power x, it's going to be 3 as y-intercept, right? And so on with the rest here. Okay, so I would like to let you guys practice on these problems. So keep in mind that we have 3.6 as match each equation with its graph and explain the reason. So think about like I said before. If you have b less than 1 and greater than 0, you will have decay, right? But if you have b greater than 1, you will have a growth. So, and you see in here, I have some, I have 3 growth factor as 1.3, 1.8, and 1.3 here. So then the growth factor, the decay factors is 0.7 here, will be the one decay, right? So there is only one decay as this k, which is kx, and also it's go through y-intercept at 4, right? So I would say a will be k of x, right ways, either one, and then reason could be like, you know, y-intercept at 0, 4, and it is decay, right? It's decay exponential function. So go ahead and try that and do the rest for me, okay? You can pause my videos and replay and play it to compare with my answer, okay? So this is my solution, and you can see that I should have a first because it was decay and go through intersect y-intercept as 0.4. For b is should be h of x, and I have y-intercept at 4 and grow. As you see that we have 3 grow, and this is only the one that have y-intercept at 4 as a of 4 here. For C and D could be a little bit challenging, but and you see that C has C go up quickly, or let's say grow faster than D. And C will have a growth factor higher than D, and I would choose G of X will be the one for C, compared to LX with factor as 1.3. So LX might be the last one, right? Okay, I'm gonna stop my 3.1.1 here, and we'll see you in the next section.